Hi guys, welcome to Unit 10, Lesson 5 notes on solving radical equations. By the end of the day, you will be able to solve equations involving radicals and identify extraneous solutions. Let's jump right in. You can solve radical equations. Remember, radical has a square root. Equation equals by squaring. You're going to square, you're going to write something squared like that to undo the radical part. So you're going to solve radical equations by squaring each side of the equation, and then it's also very, very important to test the solutions. So today we're squaring and we're testing. We're checking our solutions. Let's jump right in. So remember, whenever you solve any equation, you want to get that variable all by itself. So we're going to start out, we have the square root of a. We want to get that all by itself. So let's undo the plus 5, or let's undo the minus 5 by adding 5 to both sides. So these will cancel out, leaving us with the square root of a equals negative 2 plus 5 is 3. So the square root of a is 3. Now we're going to undo the square root by squaring, which you do to one side, you have to do to the other side. That gives us that a is 9. Now let's check our work. We're going to plug it back into our original equation. Our original equation said the square root of a minus 5 equals negative 2. Now let's check it. The square root of 9 minus 5 is negative 2. Well, square root of 9 is 3 minus 5, negative 2. All set. That's right. We did it. We squared, we checked. Let's do it again. Oh, hey, look, we have 2 radical signs this time. Okay, so let's go ahead and square both sides, and conveniently, that will get rid of both radicals, leaving us with just 7b minus 4 equals 5b plus 10. Again, by squaring both sides, we undid those radicals, so they cancel out, leaving us with just this equation, and you know how to solve that. We're trying to get b all by itself, so let's get all of our b's on the same side. So we'll subtract 5b from both sides, leaving us with 2b minus 4 equals 10. Add 4 to both sides, so 2b equals 14, dividing by 2 gives us b equals 7. Let's go ahead and check our work again. Our original equation said the square root of 7b minus 4 equals the square root of 5b plus 10. If we want to check our solution, we need to take this b equals 7, plug it in right there. So that means instead of b, we're going to write 7. So is it true that, well, 7 times 7 is 49 minus 4, and 5 times 7 is 35 plus 10? Well, 49 minus 4 is 45, and 35 plus 10 is 45, and I don't know about you guys, but I think that's the same thing. So yes, true. That is a true statement. Our solution works. So, just like we said, if you want to solve a radical equation, square each side and make your solution, or check your solution. So we did. We squared each side and we checked our solution. Super. Great, right? Okay, Miss Van Dyke, but when are we going to use this in real life? Well, you're going to go into clockmaking. Let's say you have a pendulum on a clock. Ooh, a pendulum. Y'all know what a pendulum is? A pendulum is if you have a clock and you've got like that thing hanging down and it goes back and forth like that. It goes tick tock, tick tock. That's what a pendulum is. So yeah, you've got this wonderful clock, and it's probably in like this super fancy kind of thing where it's got like the window and it's this big old like giant clock, right? that kind of thing. And the pendulum is the thing that switches back and forth. Okay, so we have this expression that tells us the time t it takes for a pendulum of a clock to do a full swing, that is go back and forth, is approximated by the equation t equals 2 times the square root of L over 3.3, where L is the length of the pendulum. Make it orange because I made the pendulum orange. Where L is the length of the pendulum. The pendulum clock completes a full swing in 1 second. Well, that makes sense, right? It goes back and forth every second. So that's our time. How long must you make your pendulum? Well, how long? That's going to be our distance. How long must you make your pendulum round to the nearest tenth of a foot? Okay, so we start it with our expression t equals 2 times the square root of L over 3.3. And we know that t, our time, is 1 second. So we can plug that in. So we know that 1 equals this whole expression. Great. Now what do? Well, we want to get this L all by itself. So we're going to undo everything happening to our L. First, let's divide by 2 to get rid of that 2. So we have 1/2 equals the square root of L over 3.3. And now we've got this square root here. What will undo the square root? Oh yeah, square. So let's square both sides. Now that we've squared both sides, let's simplify. So here, when we have a fraction with an exponent, we can distribute that exponent to the numerator and to the denominator. And on the other side, our square root and our square will cancel out. That's good because we wanted to get rid of the square root. Awesome. Okay, well 1 squared is 1, 2 squared is 4, equals L over 3.3. Now I've run out of room on my page, so I'm going to start a new column. And we're almost there. All that's left in our whole mission to get this, to get this L all by itself, we just need to multiply times 3.3 on both sides. Because we have divide by 3.3 times 3.3. Those cancel out, giving us that L equals 3.3 divided by 4. Cool. That's not a simplified fraction, but that doesn't matter because it asks us to round to the nearest tenth of a foot. So at this point, guys, let's just plug it into our calculator. And we get 3.3 divided by 4. That's equal to 0.825, which rounds to 0.8. Ta-da! So our clock is, 0.8 feet. That's not very tall. We got a very short clock. Oh well, short pendulum on our clock. Cool beans. Okay, we're halfway there. Here we go. So we had lots of fun on our first page, but we have something that we need to check for. Let's go and review real quick. If we were in class, I would ask you what extra meant. Like, you'd be like, oh, she's so extra. Like, what does that even mean? So you'll have to tell me. Maybe I'll make it a question. I should do that. You have to tell me what extra means. I can tell you that I know that an extraterrestrial is... Do you guys know what an extraterrestrial? I didn't even spell it right. An extraterrestrial is? Well, this extra means outside of. And a terrestrial, well, like la tierra, terrestrial, means earth. So something that comes from outside of earth is an alien. That's why you have the movie E.T. It literally is E.T. the extraterrestrial, because he's from outside of earth. Or for my Spanish speakers out there, if you are an extranjero, well, extranjero is another word for a foreigner. which you can also say is an alien, like politically. Haha. You're noticing a theme here? A foreigner, someone from outside the country. Extra means outside. So when we're talking about something that is extra in mathematics, when we talk about a solution that is extra, that is, it's outside, we say it's extraneous. Extraneous. An extraneous solution is one that does not satisfy the original equation. That is, it doesn't make the original equation true. So when we say it does not satisfy, that means it doesn't make the original equation true. So what we have to do when we get a solution is we have to check it. That's super important. We need to check our solution to make sure it makes the equation true. So here we go. I didn't copy the equations down correctly. So let's go ahead and just rewrite them real quick. Say you start out with negative c equals the square root of c plus 6. We're going to solve that one. And while I have it written down right here, I'm going to copy it down here later so that we can check our work with it. Cool. And also while we're writing, number 4 should not be this equation. It should be 6 minus the square root of 2d equals 10. Okay, here we go. Oh yeah, I'm going to copy that. Thank you for your patience. Here we go. So here, we've got a radical on this side, and I want to get rid of that radical. How can I undo a square root? You're right, I want to undo that square root by squaring. So I'm going to square both sides. Now negative c times negative c gives us a positive c squared, because we have negative c times negative c. Well, that's equal to negative 1 times negative 1 times c times c. Well, negative 1 times negative 1, that's 1. C times c, that's c squared. So that gives us on this side c squared. And on this side, our square root and our square cancel out. That's the whole reason we did it in the first place. It gives us c plus 6. Okay, cool. Now let's get everything on the same side. So we're going to subtract c from both sides. Oh, both sides, please. Thank you. Giving us c squared minus c equals, oh, those cancel out, 6. Fun. Now we're getting everything on the same side. So let's subtract 6 from both sides too. Wait, Miss Van Dyke, it seems like you're only making this problem more complicated. Are you sure you're doing this right? Wow, look at what we have, you guys. We have a quadratic equation. Amazing. You ready? Let's factor it. So this gives us 2 factors that will be equal to 0. Now we can go through and do the magic X thing if you want, and we have c and c to get our c squared, and we need something that multiplies to negative 6. Let's see, what adds up? Again, we're looking for things that add up to negative 1 and multiply to get negative 6. I used gray, didn't I? And we will want negative 3 and a positive 2. So negative 3, positive 2 are our factors. Now to solve this, we need to split the sky equal to 0. So we have c minus 3 equals 0, and c plus 2 equals 0. Solving on this side, we add 3 to both sides. So c is 3, this side, we minus 2 from both sides. C is negative 2. Cool. That was fun. I didn't realize how small I was writing. Oh well. I can always do this, right? Nice. That's much better. Now we need to check our solution for each of those, because we want to make sure that neither of these is extra, that it's extraneous. So we're going to plug it into the original equation to make sure it is true. Hey look, how convenient. We have our original equation here. So let's plug each of these guys into our original equation to see if it works. Yeah. Okay, so we're going to start out with c is equal to 3. Is it true that negative 3 is equal to the square root of, 3 plus 6? Well guys, I can tell you right now, square root is not negative, so no, it is extra. Did I make this red? I did. Extraneous. Oh, and let me tell you why. I got ahead of myself. I'm so sorry. So we keep this negative 3 going, and then we have the square root of 9. But the square root of 9 is 3. So this is extraneous. So there you go. Let's test our other side. Again, we thought that c equals negative 2, so we're going to plug a negative 2 in for that c. That gives us a negative 2. Shoot, guys, let's just say that's positive. Okay. Positive 2 equals the square root of negative 2 plus 6. Well, that's 2. It's the square root of 4, and the square root of 4 is 2, and 2 is 2. That's 2. Cool. You could even say it's radical. No, so it worked. We got an extraneous solution. When we get an extraneous solution, we cross him out. That doesn't work. Don't include him. So our only solution here is that c equals negative 2. One more. Here we go. I'm going to predict that this ends up here somewhere. All right. We've got c minus square root of 2d equals 10. Well, if we want to simplify this guy, first we want to get our radical all by itself. So let's undo what's happening to our radical. We'll subtract 6 from each side. This gives us the negative square root of 2d equals 10 minus 6, 4. Cool. Then negative, so we need to make everything else negative. So we divide by negative 1, divide by negative 1. So we get the square root of 2d equals negative 4. Fun. Next, we need to undo our square root. How do we undo a square root, you guys? Let's square it, because at this point it's hip to be square. Okay, here we go. We get 2d equals negative 4 times negative 4. Okay, negative 4 times negative 4 equals, well, negative times negative is a positive. 4 times 4 is 16. Give us a positive 16. And then we divide by 2 to get that d is in delta all by itself. So d is equal to 8. Oh, that's my favorite number. I didn't even do that on purpose. Cool. So we get d is 8. We're almost there. Let's check our work. So we'll plug it back into our original equation. If we claim that d equals 8, we're going to put 8 in right there. Okay, so that gives us 6 minus the square root of 2 times 8 equals 10. Maybe? I don't know. Let's find out. So 6 minus the square root of 2 times 8 is 16 equals 10, I think. Well, square root of 16 is 4. And 6 minus 4 is not 10. It's 2. So no, this is not true. This is extraneous. Aww, that was so sad. So no, you're done. b does not equal 8. Sorry, guys. In fact, wait, that was our only solution. So if that doesn't even work, we say this has no solution. Oh well. It'll survive. Right? Of course it will. Again, to solve both of these, we had our radical expression, so we got to square it to clear it out. And then we check our answers to make sure that they actually make sense in our original equation. And those are our big ideas of the day. Solve your radical equation by squaring, and then test your solutions to make sure they work. I hope you enjoy your homework.